So for our second lesson today, we're going to solve exponential equations. So now we're going to solve equations that have exponents that are variables. Remember, here we have b to the x power. B is your base, x is your exponent. We're looking to, for our first step, to rewrite both sides of the equation so that the bases match. So for this example down here on the left, our bases for both of these are 6s. Once your bases match, then you can set the exponents equal to each other, solve for x, and then check your solution to make sure it's accurate. So we're going to practice those 4 steps on this next page. So looking at question number 1 on this page, first thing we're going to do is check our bases. Do we have the same bases? Yes, if your bases match, you're setting your exponents equal to each other. Well, that one's pretty straightforward. You just have x equals 4. For the next one, check your bases. I have bases of 6 and 6. So my bases match. I can cancel my bases out, leaving me with 5 plus y equals 3. If 5 plus y equals 3, I can solve for y by subtracting 5 from both sides to get a value of -2 for y. So y equals -2. The third one, getting a little bit more complex. Again, our bases match, so we can cancel them out, leaving us with x minus 5 equals 3x plus 13. Excuse me. Subtract x from both sides. That gives us -5 equals 2x plus 13. Subtract 13 from both sides. So -18 equals 2x. Beside it, divide it. We're dividing both sides by 2 to get x equals -9. There we go. So here are 3 pretty straightforward examples. The bases automatically matched. Anytime your bases match, we can cancel them out. Set your exponents equal to each other. For the next one, you'll notice this time we don't have like bases. So when I compare these two, they're not in any way, shape, or form the same number. So when this happens, and this happens the majority of the time, you want to rewrite so that they're the same base. So I want to figure out 6 to the something power that'll give me 1,296. So in my calculator, I know that 6 squared is 36. So I'm going to take 6 to the 3rd. If that equals 1296, then that's what I want. If it doesn't, I'm going to move to 4, 5, 6. So 6 to the what power is 1,296. So in your calculator, 6 caret key, start with 3 and work your way up. Yep. 4 is your magic number. So if you haven't found it, take 6 to the 4th power. 6 to the 4th power is 6 times 6 times 6 times 6, which is 1,296. So now we've taken that 1,296. We've not changed it. The right side still equals 1,296. We've just written it differently. So 6 to the 4th is the same as 1,296. But now, when I look at my bases, they're both 6s, so I can cancel them out. If I cancel them out, that leaves me with 3x plus 4, the exponent on the left, equals the exponent on the right, which is 4. Now I have a basic algebraic equation to solve. Oops, I wrote 4. So 3x plus 1 equals 4. You would subtract 1 from both sides to get 3x equals 3. Beside it, divide it, and x equals 1. Final answer. Questions on this one? So we rewrote the right side so that it had a base that matched the left side. Set our exponents equal, then we went ahead and solved for x. On the next slide, we have 6 to the 3x plus 1 equals 1. And then I've asked us, how can we rewrite the right side so that it has a base of 6? So I want to rewrite the 1 to be 6 to the something power. So this is going to be 6 to the 0 power. If you don't believe me, type 6 to the 0 power in your calculator. So really keep in mind that anytime you have 1, you're going to use an exponent of 0 with whatever base you want. It doesn't matter the base. I could change that to any base I wanted. We picked 6 because the left side had a base of 6, and now my bases match. Since my bases match, I can set my exponents equal to each other. 3x plus 1 equals 0. Subtract 1 from both sides, so 3x equals -1. Beside it, divide it, and x equals -1/3. For this one, now we have a fraction. We want to rewrite that fraction to be a base of a 5. How did that become a fraction? The answer to that is it became a fraction with a negative exponent. So negative exponents are what cause these fractions. We want to figure out what kind of exponent it would take to flip it. Well, we know it's got to be negative, but we really need 5 to the what power will give us 625. Yep. So 5. So 5 to the 4 is 625. Since it's in the fraction, we're making it a -4. If you don't believe me, take 1 divided by 625, and then take 5 to the -4th power, and it's going to give you the exact same thing both times. So since we had this fraction, this is just a negative exponent. Now we have like bases. We have bases of 5s on both sides. Cancel them out. and we're going to solve 4 minus x equals -4. Don't lose your negatives or your minus signs. I would subtract 4 from both sides to get -x equals -8. Got to get rid of that -1 sitting there in front of the x. You can either divide by -1 or multiply by -1 to get x equals +8. Final answer. Questions on this one? You do have one of these on your homework assignment. So fraction, use a negative exponent. In this case, 5 to the 4th gave us 625, so we replaced it with 5 to the -4th because it was in that fraction. Sometimes you have to change both bases. So notice for the question on the left, I have bases of 2 and 4. This, to get the same base, I conveniently can rewrite 4 to be a base of 2, so I can get those to match. But when I go to the question on the right, I can't rewrite 125 as a base of 5. Because if I take 5 to the first, it's 25. 5 squared is way over 125. So on that question on the right, we're going to have to rewrite both bases because we can't rewrite one to be the other. So we're going to work through the problem on the left first. We're going to rewrite this 4, because 4 is 2 squared. But since there's already information up there in my exponent, it's got to go in parentheses. So that right side actually becomes 2 squared for the 4, and then in parentheses still up there in the exponent is the x minus 2. So this right here is me rewriting with like bases. Again, once I have my like bases, I can cancel the bases out, set the exponents equal. So x plus 3 equals 2 times the quantity x minus 2. Got to get rid of those parentheses. The easiest way to do it is just to distribute that 2. So 2x minus 4. And then we're back down to a basic algebraic equation to solve for x. So subtract x from both sides. Add 4 to both sides. And x equals 7. For my final answer. And then definitely the trickiest problem on here, I want to say you don't have any on your assignment, but you might see one in the future. So we're going to do it. We want to rewrite both bases. So again, we can't rewrite 125 to be a base of 25. So we want to figure out what base will work with both of these numbers. Well, since I have 25, I'm going to look at it first. The easiest or the simplest way to rewrite 25 with an exponent would be 5 squared. 5 squared is 25. But then I have to think, can I rewrite 125 to also be a base of 5? Well, yes. 5 to the third is 125. So then I'm going to keep that. So my new exponents get added up with my old ones. The old ones get put in parentheses. Now my bases match. I can cancel them out. And I have 2 times x minus 1 equals 3 times 4x. We're going to distribute. 2x, or 2 times x is 2x, 2 times -1 is -2, and then on the right side, 3 times 4x is 12x. Subtract 2x from both sides. So now I have -2 equals 10x. Beside it, divide it. -2/10, which reduces to -1/5. Leave it as a fraction, convert it to a decimal. Whatever makes your heart happy. On the next page, you will see your assignment. There are 10 questions for you to work on.